Welcome back, and I've got another fun experiment for you today. We're going to be looking at the effect of internal resistance. And then all you do is just put your drink down on the bar and you leave it alone. I'm not sure you expected that to happen, and neither did I. So let's try and explain what's happening. Electric fields apply forces to charges. Why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees? So we're going to do a fairly simple experiment to begin with, and bear with me because it is going to get a bit more difficult later on. So I've got 4 cells in series here, and I'm going to connect my lamp to one cell, so it's fairly dim. As you'd expect, 2 cells, twice the voltage, 3 cells, and 4 cells, 4 times the voltage, so we're up to 6 volts across the lamp. Let's have a bit more voltage, so we'll connect another power supply in series. And there's our 6 volts, 7.5, and we'll keep going up in voltage and see what happens to the lamp. So it's pretty bright now. That's 12 volts, and it might be worth trying with just a little bit more voltage. So I'll bring in another power supply, connect that in series, and we're now at the 12 we had before. 13.5, and you can see the lamp getting brighter and brighter. We've blown the lamp. So we've only got up to about 15 volts and we've broken the lamp. So with 15 volts, we blew the lamp, and we've got to throw this out now and get a new lamp. So what I'll do is I'll get a replacement. Here we go. And just check it's all working. Yeah, that's absolutely fine. So let's have some fun. Let's change our power supply now, not for one that is about 15 volts that we had before, but let's wheel out the big guns. This is an EHT power supply. This will give us 5,000 volts. Right, we've got our EHT, extra high tension power supply here, and that will give us a maximum voltage of 5,000 volts. And just to show you that this thing means business, I'll connect one wire into the positive and one into the negative. Turn up the voltage so you can see the LEDs show that we've got 5,000 volts, and just hold the wires together. And I don't know if you can see, but I can certainly hear there's a spark forming between those two terminals. So there's enough voltage on there to ionize the air. Right, so if you remember, 15 volts was enough to blow this little lamp. So let's have some fun. Let's connect it across a 5,000 volt power supply. So here goes. I'm going to turn the power supply up to 5,000 volts, and I'm going to connect the negative, and I'm going to press the positive into the lamp's connector. What do you think is going to happen? So here goes. Let's see if you're right. 3, 2, 1, go. Oh, well, that was all pretty uneventful. You might notice actually that the voltmeter on the power supply has dropped to 0, and I'll just disconnect again and see what happens. Back it goes again. Now this is all very odd and will need some explaining. But before I go for an explanation, I think I'd better just prove to you that this lamp here is still working fine. So I'll get the battery pack, connect it in, and the lamp's absolutely fine. It hasn't been blown. I haven't cheated here. So I'll need to explain why when we connect a lamp to a 5,000 volt power supply, 5,000 volts doesn't seem to be enough to blow the lamp, and yet 15 is. There's an interesting bit of physics going on here. So to explain this, it's quite difficult. It's really an A-level concept. That if we connect into a power supply, there actually isn't one thing in series with resistance. So I'll just turn up the power supply and connect in, and the bulb doesn't just blow up in my face. Okay, what's happened here is we've got two things in series. The bulb has resistance and the power supply has its own internal resistance. And the voltages will split across those resistances depending on their values. So if we've got 5,000 volts to play with and the lamp has a low resistance, it will get a low voltage across it. And the power supply has a high internal resistance, most of the voltage will be lost across the internal resistance of the power supply. And what that means is it can't drive very much current. If I disconnect, the external resistance now is very, very high, so most of the voltage is found across the external resistance, and there it is, visible on the voltmeter that measures that. So let's take that just a tiny bit further. I'll connect my lamp up to 6 volts again, and of course you'll be unsurprised that it lights the lamp. But remember that this circuit has two resistors in it. It has the resistor that's the lamp, and it has the resistor that's the internal resistance of the cells. And the more interesting thing to do is to disconnect the lamp and get rid of it. And if you know a little bit about Ohm's law, if I was to touch these two terminals together, if the resistance here becomes 0, the current should become infinite. And it doesn't. Okay? So what we've got here is a voltage and an external resistance that's very low. So most of the voltage is found across the internal resistance of the power supply. And I'll tell you next why that's good news. So for teachers like me, thankfully batteries, cells, have an internal resistance that's measurable. And what it means is that if students short circuit the batteries, they don't get a very low resistance and therefore an incredibly high current as you would with arc welding. Because there's quite a high resistance in the cells, the maximum current it can drive is actually quite low, which makes them safe. And our EHT power supply has a very, very high internal resistance, which means the current we can get from it is very low indeed, which also makes it very safe to operate. But something like a car battery has a very, very low internal resistance. So if you short circuit a car battery, the total resistance of the circuit is very low and the current will be very high and you'll end up melting what you were dealing with. Again, that's the sort of principle in electric arc welding. So, as ever, there's a lot more I can say about internal resistance. But for this video, all I want to say really is, whenever you see a series circuit, it doesn't have one resistor in it, it has two in series. And the internal resistance of the power supply is what limits the amount of current that you can get out. So, I hope you enjoyed that video, and I look forward to seeing you again next time.